Hello all, I'm Chen Junyo, and now I would like to talk about Form 4, Chapter 3, which is Logical Reasoning. So in this chapter, what we need to learn is statement and argument. And in the statement, I have 4 subtopics, which is quantifier, negation, compound statement, and implication. And in the argument, have only 2 subtopics, which is deductive and inductive. After that, what is a statement? Statement is a sentence that can be determined as either true or false. Like for example, 1 plus 1 equal to 2. This is a statement and it is the truth. And if I give 1 plus 1 equal to 3, and it also a statement, but the statement is false. And here have a tips for determine the sentence, determine the statement, which is that sentence that has question mark, exclamation mark, and please are not a statement. Let's come to see the question. So the question is, determine following sentence is a statement or not. So the first question is 4 over 8 plus 0.5 equal to 1. It is a statement and it is true. And the second question is, how are you? As you can see here, a question mark. So it is not a statement. And the last question is, minus x is more than minus 100. This is also a statement and this is false statement. Have a question which is, determine the following statement is true or false. If false, give the reason why. So the first question is square root of 99 equal to 4. This is false because square root of 99 is equal to 3 square root of 11. And the second question is 8 times 8 is not equal to 64. And this is false also because 8 times 8 is equal to 64. But here, as can you see, the question is right, not equal. So the last question is, the formula for all the area of a circle is pi r squared, which is true. So this 3 is a statement and have false, have true. Is the quantifier. So this quantifier is quite easy. You will only learn how to use all and some. As the example, as you can see here, animal have 2 legs. And here, not all the animal have 2 legs only, right? Like the lion have 4 legs, like the horse have 4 legs. So here you need to write some. Some animal have 2 legs. So the second question is, even number can divide by 2. So is all the even number or some the even number? Is all the even number can divide by 2 because 2 can be divided by 2, 4 can divide by 2, 8 can divide by 2, and also so then after that negation. So in negation, you will only need to learn how to use not and no. Just use no and not to change the statement only. So here I have an example. The first question is, example is, all radians of the circle is 4 cm. And in negation, it will become all radians of the circle is not 4 cm. After that, the second example is 5 is an odd number. And during negation it will become 5 is not an odd number. So it's easy like this. Have some question, which is negation all of the following statement and determine whether it's true or false. So as you can see here, this is the last question, last example. all radians of the circle is 4 cm, and you negation it, become all radians of the circle is not 4 cm, and it is true. The radians of the circle can be any number. And the second question is 5 is an odd number, and you negation it, become 5 is not an odd number, and it is false. 5 is an odd number. So the last question is 85 minus square root 4 equal to 82. And you negation it will become 85 minus square root 4 not equal to 82. So it is true. After that, we would like to learn about the compound statement. And in compound statement, we will need to use and or all to compound two statements. For example, like here, as you can see, 5 plus 5 equal to 10 is a statement. And 10 minus 5 equal to 5 is also a statement. So I use and compound it. And the second example is square root 100 equal to 2 is a statement. And 2 over 4 equal to 0.5 is also a statement. So these I use all. Here, have some question. Determine the following compound sentence are true or false. So here, as you can see, have the tips. And tips 1, and if the compound statement is n, only 2 correct can be true. And if the compound statement use or, only 2 wrong can be false. So we can see the question first. First question is 5 times 5 equal to 25. This is true, right? And square root of 25 equal to 5. This is also true. So if n and you get true correct, you get true. So the answer is true. Second one is 2 over 4 plus 4 over 8 equal to 1. This is true. And here I use n. And the second statement is x over 8 equal to 1. And this is false. This is not true, this is wrong. So if here is used n, 1 correct, 1 false will become false. Because as you can see here, only 2 correct can be true. So the next question, 5 power 3 equal to 444. This is false, not correct. So here I use all, and 99 power 0 equal to 1. This is true. So here you will get true, because only two wrong can be false. So here is 1 wrong only, so you will get true. And last question is 1.25 times 33 equal to 33.25, which is wrong. And here I use all, and 45.5 equal to 45 over 5, which is over wrong. That also wrong. So if 2 wrong, I will get false in this question. After this is implication. And in this implication have 3 types of question. And the first type is if P then Q. And the P will become antecedents, and the Q will become the consequence. And the second type is P if and only if Q. And you will need to let the sentence become 2 implication, which is if P then Q, or and if Q then P. So the last is convert the statement. Just need to convert the statement using converse, inverse, and construct positive. And here is the first type of the question. And the first question is if 5x equal to 25, then x equal to 5. So you will need to find out the antecedents and the consequence. So the answer will be antecedents is 5x equal to 25. Consequence will be x equal to 5. So the second question, it give you the antecedents and the consequence, and you will need to do a statement. And here is the answer. It's just you need to add the if at the front of the antecedents and need to add a then at the front of the consequence, which is if I like to eat McDonald's, then I don't like to eat KFC. It's quite easy, right? So here is the second type question. And the first question, it will give you a statement which is x union y equal to x if and only if y subset x. So you will need to find out two implications in this statement. So the answer is if x union y equal to x, then y subset x. And the second implication is if y subset x, then x union y equal to x. And the second question will give you the implication and you will need to do a statement. So here is the answer, which is x equal to 1 if and only if square root x equal to 1. Here is the last type of the question. So here have a statement is if x plus y equal to z, then z minus y equal to x. So you would like to do the converse. So the answer is if z minus y equal to x, then x plus y equal to z. Just take the first equation to the back and take the second equation to the front. It's quite easy, right? And the second is inverse. So for inverse, you just need to negation the two equations like this. If x plus y is not equal to z, then z minus y is not equal to x. So this is the inverse one. So the last construct positive is let the first equation to the back and let the last equation to the front and negation these two equations. So the answer will be if z minus y is not equal to x, and then x plus y is not equal to z. So it's quite easy, right? So the is argument. So in argument, like just now I say have deductive and in inductive. So in deductive is making a specific conclusion based on the general premise, and in inductive making a general conclusion based on the specific premise. In deductive here, as we can see, have a table which you must remember it, and this table have three forms, and these three forms need three things, which is premise 1, premise 2, and conclusion. As you can see, the first form here, the premise 1 must be all x are y, and the premise 2 must be z is x, and the conclusion will become z is y. So and the same for form 2 is the form 1 is or use all right. So at the form 2 I will use the if p then q. So p is the true and q is the true. So for the last form is quite same as the form 2. the premise one is also P if P then Q, but the premise two will become not Q is true, and the conclusion will become not P is true. So here is some example for the form 1, and the first question is, all the herbivore eat plant. Deer is a herbivore and deer eat plant. So you will take these 3 sentences to premise 1, premise 2, and conclusion. And this is quite easy. Just take the first one. As you can see here, all herbivore eat plant. So as you can see here, all X are Y. So the herbivore is X and the plant is Y. So you can put at the premise 1. And you see the second statement, deer is a herbivore. So you can see here, the premise 2, C is X. So this herbivore is dead, and the deer is this herbivore is X, and the deer is dead. So you can put this sentence in premise 2. And the last is deer eat plant. So the plant is Y. See here Y. Deer is dead. So you can put this and this statement in the conclusion. It's easy like this. So next is form 2. So in this form 2, I would like to do a question like, I give you premise 1 and premise 2, and you will find out the conclusion. Okay. So if x is a positive number, then x is more than 0. And the second premise is x is positive number. So what will become the conclusion? Is x more than 0. It's quite easy, right? This is form 2. Because here, as you can see, you use if, and this is not like form 3 have the negation. So at here, it's same the form 2, but here I give you a premise 1 and conclusion, and I didn't give the premise 2, so you need to figure out. So the premise 1 is if 999 times x equal to 0, then x equal to 0. And you don't know the premise 2, and the conclusion is x equal to 0. So follow the form 2. The premise 2 is 999 times x equal to 0 is the premise 2. As you can see. Here is the last form, which is form 3. And here, and this question, I would like to give you the premise 2 and the conclusion, and you will need to figure out the premise 1. So this is quite hard, and the premise 2 is room temperature is not higher than 22 degrees Celsius, and the conclusion is it is not a sunny day. So for the form 3, the premise 2 and the conclusion must be the negation of the premise 1. So the answer for the premise 1 is, if it is a sunny day, then the room temperature is higher than 22 degrees Celsius. Is this only? So the last of this chapter is inductive. In this inductive, only have one type of question. It's based on the equation and sequence, find out the conclusion. So what is the equation? Here, as you can see here, 3 is the equation. And what is the sequence? Is 7, 14, 69. And how I get this sequence is here. As you can see from the equation, the answer of the equation, the first is 7, 14, 69, and so on. So in this question, what we need to do is just write out the conclusion, which is we take the never change, the number never change, and the number never change, like 5 at here. The first equation 5, the second is also 5, the third is also 5. So I just take the 5 put here, and plus bracket 2, as you can see here, 2, and the second equation will become change to become 3, and the third will change to become 4. So this is the not the never change. So I just put the x here, and don't see the plus one first, see the power first. The powers is also 1, 2, 3, no change. So I write x also. And why I write plus 1 here, as you can see, if the power is 1, the number inside the bracket will become 2. So it's just plus 1 of the number. So I just write plus 1 here, will become the answer. As you can see, if x is 1, so here x plus 1 means 1 plus 1 become 2. So here is 2. If x is 2, so x plus 1, x is 2, 2 plus 1 is equal to 3. So on. And here finish the equation, and you will write the sequence, which is x equal to 1, 2, 3, and so on. So you just need to write total. This is all in this chapter. Thank you all. See you.